all of you in my class. I am Professor Adesh Kumar Srivastav, Associate Professor, School of Management, BBD University, Lucknow. Today I'll be talking about ER diagram. ER diagram. ER diagram is a visual representation of data that describes how data is related to each other. In ER model, we disintegrate data into entities, attributes, and set up relationships between entities. All this can be represented visually using the ER diagram. This is entity relationship diagram which displays the relationship of entity set stored in a database. In other words, we can say that ER diagram help you to explain the logical structure of databases. At first look, an ER diagram looks very similar to the flowchart. However, ER diagram includes many specialized symbols and its meaning make this model unique. The purpose of ER diagram is to represent the entity framework infrastructure. ER model is a high-level conceptual data model. ER modeling helps you to analyze data requirements systematically to produce a well-designed database. The entity relationship model represents real-world entities and the relationship between them. Now we come to the components of ER model. The components are entities, attributes, relationship, etc. From the component of ER diagram, there are defined symbols and shapes to represent each of them. We will discuss it now one by one. Rectangle. We use rectangle to represent entity set. In the same way, we use ellipses to represent attributes, and we use diamond to represent a relationship set, and we use lines. They link attribute to entity set and entity set to relationship set. Likewise, we use double ellipses to represent multi-value attributes and dashed ellipses to represent derived attributes. Double rectangle to represent weak entity sets. Double lines to represent total participation of an entity in a relationship set. So now we'll be discussing all these shapes one by one in a detailed way. As I told you, you can see now this is a graphical representation as we do in ER diagram. Entity or a strong entity we represent by rectangle, weak entity by double rectangle, attribute by oval, multi-valued attribute by double oval, relationship by diamond or rhombus, and weak relationship by double rhombus. Now see what we do. The entity name. Entity name is what? An entity can be a person, place, object, event, or concept about which data is to be maintained. For example, a car or a student. Now what is relationship? Relationship that represent actually the association between the instances of one or more entity types. For example, here the relationship may be a blue car belongs to student Jack. As you are seeing in the diagram, there is a blue car and there is a student. So what may be the relation? The relation may be a blue car belongs to Jack. Now what are attributes? See, these attributes are, what are attributes? These attributes are property or characteristics of an entity. For example, color of the car may be one entity, name of the student may be another entity, his date of birth may be another entity, the model of car may be another entity, the make of the car may be another entity. So attributes. I'm sorry, these are attributes. So name of the student entity and example of car color of car entity. These are attributes. Attributes of entities. Now, what is an entity? An entity can be any object, place, person, or class. In ER diagram, an entity is represented using rectangles. Consider an example of an organization: employee, manager, department, product, and many more can be taken as entities in an organization. Here, it's a simple diagram, ER diagram, which represents the relationship between employee and a department. Here, one entity is employee and another entity is department, and the relationship is works for, means the employee works for department. So the rhombus in between represent a relationship. We call it a diamond also. So I hope by this simple figure, the ER diagram must have got a shape in your mind. Now, weak entity. Weak entity is an entity that depends on another entity. Weak entity does not have any key attribute of its own. Double rectangle is used to represent a weak entity, as we discussed earlier. Now, for an example, installments may be a weak entity. Why? Because it depends on loan. The installments of the loan, or you can say the EMI, which we call, is always dependent on loan. As per the loan, the EMI differs. So this may be a weak entity. Now, types of attribute. The key attribute for an entity: to represent a key attribute, the attribute name inside the ellipse is underlined. See, if we are representing a simple attribute, it will be represented through an oval shape. But if we are representing the key attribute, what we'll do is within oval, we'll put a line here like this. And then there is another attribute, that is derived attribute. Derived attribute are those which are derived based on other attribute. For example, age can be derived from date of birth. So to represent a derived attribute, another dotted ellipse is created inside the main ellipse. As you are seeing in the figure, that there is a oval, and there under that, within that oval there is a dotted oval, right? So this is representing derived attribute. Now, multi-valued and composite attribute. Multi-value attribute for an entity. Double ellipse, one inside another, represent the attribute which can have multiple values. So if a multiple values are there in any attribute, this will be represented by double ellipse. For example, a mobile number may be a multi-valued attribute, because nowadays a person may have more than one mobile number. It is very natural that a person may have more than one mobile number. So if there is a column in the database, or you can say there is an entity in which you have to write attribute as a mobile number as an attribute. So if you have to write the mobile number, there may be more than one mobile number in any case. So that will be a multi-valued attribute, those who have more than one value. Now we come to another attribute, that is composite attribute. Composite attribute is attribute which also has attributes. Means a composite attribute is derived by is composed by few other attributes. For example, you take my name, Adesh Kumar Srivastav. So it is a composite attribute. Why? Because there are three component of this. There are three attributes. Number one is first name, number two is middle name, and number three is surname or title name. So these three are the attribute which are making it a composite attribute. So the composite attribute is that attribute which is derived from other attribute, or you can say which also has attributes. Now we come to the type of relationships. There are three types of relationship that exist between entities. Number one, binary relationship. Number two, recursive relationship. And number three, ternary relationship. So these are three basic kinds of relationship that we have. Now, binary relationship means relationship between two entities. This is further divided into four types. Means binary relationship is further divided into four types, that is one to one relationship, one to many relationship, many to one relationship, and many to many relationship. Now we will see this in other slides. Now we first we'll first discuss one to one relationship. Binary relationship means relationship between two entities. This is further divided into four types as we discussed. So first is one to one relationship. This type of relationship is rarely seen in real world. Means one entity, there is relation with another one entity. Both sides there are only one entities. The above example describe that one student can enroll only for one course. Means one student can enroll only for one course. Here you are seeing one, here also you are seeing one. And one course, a course will also have one student. Means that course may not have more than one student. So this is not what you will usually see in the real world relationships. That's why we said that this type of relationship is rarely seen in the world one to one relationship. Means there may not be more than one student who opt that course, as well as there cannot be more than one course for a student. So it's a rare relationship that is practically seen in the real world. Now one to many relationship, there is a example below. The below example showcase this relationship, which means that one student can opt for many courses, but a course can only have one student. It sounds weird. This is how it is. So one to many relationship means there may be more than one course, there may be n number of courses, but the student will be only one. There will be only one student for all those courses. Rare to see. So this is also looks something impractical. This reflects, now we come to many to one relationship. It reflects business rule that many entities can be associated with just one entity. For example, a student enrolls for only one course, but a course can have many students. So this is very practical example that there are n number of student, right? They enroll for one course. So this is called many to one relationship. Now we come to many relationship. The diagram represents that one student can enroll for more than one courses, and a course can have more than one student enroll in it. Means there may be n number of students which enroll in n number of courses. So this is called many to many relationship. This is also we can see in the real world. Now we come to another type of relationship, that is recursive relationship. When an entity is related with itself, it is known as recursive relationship. For example, employee manages and managed by employee. Again, this will go like this and keep on going like this. So this is a recursive relationship which is repeating itself. That employee manages and managed by employee. Employee manages employee and employee is managed by employee. So this is recursive relationship. Now we come to third kind of relationship, that is ternary relationship. A ternary relationship involves three entities. In such relationships, we always consider two entities together and then look upon the third. For example, in the diagram above, we have three related entities, that is company, product, and sector. To understand the relationship better or to define rules around the model, we should relate two entities and then derive the third one. So as you are seeing in the diagram, there is a sector, one entity, product, another entity, and company is another entity. So the above relationship involves three entity, and the company operate in sector producing some products. So it is a relationship which is showing among three entities. So this is ternary relationship. If we represent the ER diagram in such a way, this is called ternary relationship. So these are all kinds of relationships that we have. Further explaining the ternary relationship, we can say a company produces many products. Each product is produced by exactly one company. A company operates in only one sector, or each sector has many companies operating in it. Considering the above two rules or relationship, we see that although the complete relationship involves three entities, but we are looking at two entities at a time. Now, what are uses of entity relationship diagram? First is database design. ER diagrams are used to model and design relational databases in terms of logic and business rules in a logical data model, and in terms of the specific technology to be implemented, that is in a physical data model. In software engineering, an ER diagram is often an initial setup in step in determining requirements for an information system projects. It's also later used to model a particular database or databases. A relational database has an equivalent relational table and can potentially be expressed that way we as we needed. Database troubleshooting. ER diagrams are used to analyze existing databases to find and resolve problems in logic or deployment. Drawing the diagram should reveal where it's going wrong. We use in business information system also. The diagram are used to design or analyze relational databases used in business processes. Any business process that use fielded data involving entities, actions, and interplay can potentially benefit from a relational database. It can streamline processes, uncover information more easily, and improve results. So it is very beneficial for business information system. We use it for business process reengineering also, that is called BPR. ER diagram helps in analyzing databases used in business process re-engineering and in modeling a new database setup. We use ER diagram in education sector also. Databases are today's method of storing relational information for educational purposes and later retrieval. So ER diagram can be valuable in planning those data structures. We use ER diagram in research. Since so much of research resources on focuses on structured data, ER diagram can play a key role in setting up useful databases to analyze the data. Now we come to the limitations of ER diagram and models. First is only for relational data. Understand that the purpose is to show relationship. ER diagrams show only that relational structure. It is not for unstructured data. Unless the data is cleanly delineated, declined into different fields, rows or columns, ER diagram are probably of limited use. The same is true for semi-structured data because only some of the data will be useful. And difficulty integrating with an existing database is another limitation. Using ER models to integrate with an existing database can be a challenge because of the different architectures. Now we come to how to draw a basic ER diagram. First, we have to define purpose and scope. Define the purpose and scope of what you are analyzing or modeling. Then we have to decide entities. Identify the entities that are involved. When you are ready, start drawing them in rectangles or your system's choice of shape and labeling them as nouns. Third is relationship. Determine how the entities are all related. Draw lines between them to signify the relationship and label them. Some entities may not be related, and that's fine. In different notation systems, the relationship could be labeled in a diagram, another rectangle or directly on top of the connecting line. Now attributes. Layer in more detail by adding key attributes of entities. attributes are often shown as ovals, as we have well discussed all the attributes and their kinds also. Then cardinality, we have to show whether the relationship is one to one, or one to many, or many to many, or many to one. So these are the cardinality. We had already discussed this also. So in this way we'll be preparing the ER diagram. Now some more tips about ER diagram. Show the level of detail necessary for your purpose. You might want to draw a conceptual, logical, or physical model depending on the detail needed. Number two, watch for redundant entities or relationships. If you are troubleshooting a database problem, watch for holes in relationships or missing entities or attributes. Make sure all your entities and relationships are labeled. You can translate a relational table and ER diagram back and forth if that helps you achieve your goal. You have to make sure the ER diagram supports all the data you need to store. And there may be different valid approaches to an ER diagram. As long as it provides the necessary information for its scope and purpose, it is good. So thank you all for patient listening and watching this, the talk of ER diagram. If you feel any difficulty in ER diagram, you can always contact me online or offline anytime when you wish. Thank you all for joining my class. Thanks a lot.